Now we want to look at how we solve an equation that doesn't contain a radical, but instead it's has a rational exponent. Okay, so like this example up here, this x squared plus 5x plus 5 is raised to the 5/2 power. Okay, we haven't seen that before, and there's no radical in there, but what we want to do is we want to undo raising to the 5/2 power. So if you think about it, I want this to become a 1. I want it to be raised to the first power. So what can I multiply, or what can I raise that to? We want to raise this to a power so that when I follow my rules for exponents, which would be to multiply, I get a 1. Okay, and so what I do is I take that side of the equation and I raise it to the reciprocal of what you see. So the reciprocal of 5/2 is 2/5. I'm going to raise it to the 2/5 power. So you're going to go to the other side. I'm going to write this up here, 2/5 power. I've got to do the same thing to the other side. I've got to raise 1 to the 2/5 power. Okay, the rule for exponents, when I take a power and I raise it to another power, it's to multiply. So if I take 5/2 and I multiply it times 2/5, I would get 10 over 10, which is 1. So you're going to get x squared plus 5x plus 5, all raised to the first power, which is just that, equals, on the other side, we have to take, since 5 is in the denominator, I'm taking the 5th root of 1 squared. 1 squared is 1, and the 5th root of 1 is still 1. Okay, how do I do this? Okay, it's a quadratic, so just like in the previous example, since you have a quadratic, you have to set it equal to 0. So I'm going to subtract 1 from both sides, which is going to leave me with, I'm going to skip all this, it's going to leave me with x squared plus 5x plus 4 equals 0. And now we want to solve that. We can solve it by factoring. Factors of 4 that are going to give me 5 would be 4 and 1. And if I set those equal to 0, I would get x equals -4 and x equals -1. And you can plug those in there to see if it works. Okay, but I've got two solutions here. If I plug in a -4, I would get 16 minus 20 plus 5. Okay, that would be a -4 plus 5 is 1. Is 1 to the 5/2 power equal to 1? And the answer is yes. Yes, it is. So that would work. And if I put a -1 in there, -1 squared is a +1. 5 times a -1 would be -5 plus 5. This would be a -4 plus 5. That would be 1 again. So both of those work. We don't throw any of them out. They both work. Okay, over here, I'm taking x plus 18 to the 3/2 power. I need that to be a 1. So I'm going to raise this side to the reciprocal of that fraction. So I'm going to raise it to the 2/3 power. Whatever you do to one side, you got to go to the other side, and you got to do the same thing. I'm going to raise that to the 2/3 power. Okay, so if I multiply a power to a power, this is where I multiply, I would get 6 over 6, which is 1. So you're just going to be left with x plus 18 to the first power, which is x plus 18. On the other side, look what happens. You have 3 over 1, and you're raising it to the 2/3 power. That's 6 over 3. Okay, if you multiply your fractions here, you're going to get 6 over 3, which is 2. So you're going to be left with x minus 2 squared. We would have to square that, so that's going to require foiling. X minus 2 times x minus 2. That's going to be an x squared. Outside product is -2. Inside product is -2. That's going to be a -4x plus 4. Okay, I'm going to just go beyond this. So I'm going to have x plus 18 equals x squared minus 4x plus 4. So what I'm left with is a quadratic. It's got a squared term, so I've got to move everything to one side and set it equal to 0. So I'm going to subtract an x, and I'm going to subtract the 18. So now I have 0 equals x squared minus 5x minus 14. Again, we've seen that before. We know that factors. Saw that on an earlier one. So that's going to factor into x minus 7 and x plus 2. So when I set x minus 7 equal to 0, I'd have to add 7 to both sides, so x would equal 7. If I set x plus 2 equal to 0 and subtract 2 from both sides, that's going to be x equals negative 2. So again, I have two values that I need to go back up, plug them in, and see if they work. Okay, so let's plug in the 7. 7 plus 18, this would be 25 to the 3/2 power. Now you got to go all the way back to section 1. How do we evaluate 25 to the 3/2 power? Well, this means square root. If I take the square root of 25, that's 5, and 5 cubed, that would be equal to 125 on that side of the equation. If I plug it in over here, 7 minus 2 is 5 cubed, and 5 cubed is 125. So that works. That's one solution. Okay, we're also going to plug in the negative 2. So if I put in a negative 2 over here, I'd get 16 to the 3/2 power. The square root of 16 is 4, and 4 cubed is 64. If I plug a negative 2 in here, I would get negative 2 minus 2 is a negative 4 cubed. That's going to equal a negative 64. Those are not equal to each other. So again, that negative 2 is an extraneous solution. And every time we've had an extraneous solution, it's been negative 2. That's just a coincidence. Okay, don't throw out negative 2 when you get it. Make sure you check it first. Okay? Give these others a shot on C. Okay, when you go ahead and you want to solve C, you've got this part of it's raised to the rational exponent. You've got to move that 14 over first. You want to isolate that rational exponent. So you'd have x squared minus 3x minus 6 raised to the 3/2 power equals negative 6 plus 14 is 8. Now you're ready to raise that to the 2/3 power. Okay, and you would do that to both sides of the equation. Okay, and this one's going to look just like B. So give those two a shot and see how you do.